Okay, this is our second video for the evening, and we are picking up at the bottom of page 53 in our book, and we're learning about the basic constructs of the Ruby language. And the section we're about to begin is called Control Structures. In some cases, and I do want to begin by just saying, right now we've been kind of working with the interactive Ruby prompt, which is on the left side of the screen. But all the things that we are learning do apply to the standard text file versions of the Ruby language too. So when you actually have a file created that has the commands in it. But you can take any of these commands and also type them into the prompt here, and they do work. And you can see actually, I was testing that because I wanted to see if the output has changed over time. But I just literally typed in the now equals time dot now, so you can see time equals time dot now, and then I just took this whole block of text and just pasted it in, and basically this part of it, pasted it, hit enter, and notice it worked. It spit back nil though as an output, which is different, but it did output time has passed. So I just want to show you that. All right, so one of the things that we're looking at here is what they're calling control structures, what in other languages we might call selection structures or decision statements, and basically where we're controlling the flow of the program depending on the current status of things. So in this example, you are looking at what we would consider a basic if statement, and notice that it works very much like it would normally. Notice really carefully though the syntax. Do you see anything weird about the syntax at all? Because there is one glaring thing that should jump out at you. It jumped out at me the first time I saw it. And notice that we have, okay, it says if, and I guess this is what we're testing, right? So if now equals time dot now, now is in the past. And of course that'll never happen because we already typed it, right? Else if, notice anything weird? Do I have to point it out to you guys?
No E?
Yeah, there's no E here. Else if is else if you want to say it like that. But that's how they do it. I think that's really kind of weird. I don't know why on earth, but I think the reason they did it is just to show that it's different. Okay, so whatever. And then else is else, and then at the end of the statement we just put the end command. So that method of writing decision statements does work. All right. Another thing that's kind of interesting is we don't have to follow that format for the syntax. Isn't this weird in this example? So this one says A equals 5 and B equals 10. And instead of saying if A is less than B, puts B is greater than A, we're doing it the other direction. Do you understand what's happening here? We're actually reversing the logic in how it's declared. We're saying go ahead and put B is greater than A if A is less than B. So we're actually doing the statement before the decision. Isn't that bizarre? And not only that, but check the second example, which is even more interesting. So there's also a keyword called unless. That's also a conditional statement. So it's saying go ahead and output A is greater than B unless A is actually less than B. So that really in essence is an if statement, but it's negated. Do you see the difference? So that's kind of a different one. Now, that's not one that, with the work I've done in this language, that's not one that I guess gravitate towards because it's just not the way I learned. But if you think about it, that's kind of how you think, right? You know, put the ice cream in the freezer if it's not, right? Unless you like it melted. Right? You know what? And I did that the other night, left the ice cream out all night long.
Kind of shake in the morning.
Well, no, I just put it in the freezer and ate it the next day.
That's what I was gonna say. You just throw it back in there, I would have.
My grandpa would open a tub of ice cream, crack a can of root beer.
All right, so once again, just that unless keyword is really kind of a way of saying if not, and that's what he says right down here. So, all right, let's move on to the next example. And while this is a loop, right? Because we should recognize while is the way to do loops, but whiles and a lot of looping structures, like while is probably the most logical one in this capacity. It does actually test for truth before it runs. So in a way, it kind of behaves like a decision statement of sorts. And that's why they put it into this category. So here we go, a equals 5 and b equals 10. So while a is less than b, we will output a is whatever it is, and then we'll keep incrementing a, and then it'll show you what it does as it keeps going. So that one's pretty intuitive, isn't it? Works like most while loops that you've seen. All right, another thing that I think we kind of briefly talked about in the previous weeks was how Ruby handles methods. And notice the keyword that they use here is def, or DEF, or for really defining something is the way that I think of it and remember it. All right, so in this case, this is not stuff that we're going to drop in at the prompt. The reason for that is it really won't execute properly, so we're just looking at it in conception. So what we're looking here is the fact that we are building some sort of a method, and then giving it a name, and then the statements inside that do whatever it does. From there on in, when we want to execute that method, we have to call upon it, just like you would in any other language. And in this case, the top of the next page here, page 55, you can see we would be echoing out time as string, and what that does is simply goes up to that method, does whatever statements are inside, and puts it up on the screen. That's real basic method definition. All right, another thing that you can do is you can, like traditional methods, pass in parameters or receive arguments depending on your perspective on it. But you can pass in values. But you notice here we do it in very much the same way we do in other languages, and that is where we put parentheses after the method name and then throw in the value. Now, because this is not a strongly typed language where we have to define what the data types are, we don't have to tell it it's a string or anything like that. We just give it some sort of a name that gets passed into the structure and then utilized. But did you notice that in the previous example, when we did the definition, even though we're not using any arguments, there's no parentheses. So that's kind of odd. That is a little bit of an oddball, so you should be aware of that. All right. All right, next section here, we're looking at classes and objects. You guys all at this point should have had, I would hope, what I would call significant exposure to object-oriented programming. I know that many of you are currently taking Java 2, but I make the assumption before you get to this class that you understand what an object is, you understand what a class is, and those things are really kind of thrown around a lot as terms in this language, kind of with the assumption that you just know what it is. From a very simple standpoint, class, we think of often as the blueprint for creating the actual thing that we're going to use. So that convention really applies to this language as well. So we will have, like, our programs will be in class files, and we can instantiate objects and then utilize those objects. And Ruby is no exception. It is an object-oriented language. All right. So if you take a look here, in this next little thing, what he's doing is he's actually building himself a multi-dimensional array. So it's really an array that contains other arrays. And because he's basically got one array that contains other arrays, this is what I would call a two-dimensional array. But it does allow you to do this type of structure just using this simple syntax here. Now, if we change this array, and this is where I think it gets interesting. All right, look at the next example where he's got two multi-dimensional arrays, one's for rowing and one's for track, and then notice how they're declared. They're declared like a normal array, but here we are actually taking those two multi-dimensional arrays and inserting them basically into a hash and then naming the whole structure. That's kind of an intensive operation, really, from like a data structure standpoint. But it, yeah, it really is. It's a way to hash things out, and it's really kind of a clever and simplistic approach, and yet very, very powerful. So, and the other thing that I guess I want to point out here is if you look at what he says right here at the bottom, you will, if you're taking this type of an approach, you then have to instantiate your class to make an instance. So even though you've defined it, you still have to turn it into the actual thing that you're using. And I think one of the conceptual leaps I see that's weak with people who are first learning programming is that concept between how is a class become an object, and the object is the actual thing that you're using, even though it's all electronic, right? But one exists in theory and one exists in actuality. So what he's talking about here is making it exist in actuality before you can actually utilize it.
I do like that thing that you pointed out.
Yeah, I think it's pretty cool. Just very simply because you're able to really kind of encapsulate really pretty complex structures into one named construct. And by virtue of doing that, you're creating a fresh object.
Yeah, and as long as you know, as long as you know what an array is, it's actually a good example for someone to understand what a hash map is.
Yep. I concur. All right, so let's get down to the nitty-gritty stuff, the class. And the standard example is that a class is like a blueprint. And what he has here is basically the output of a file. I'll make this a little narrower and get it all on the screen at the same time. You can see at the top we do use the keyword class. He is, by convention, adding the capital S at the beginning of the name of the class. Inside that class we have a number of named methods. Notice that some of them just have a name, some of them have parentheses that follow. Notice the format for doing comments, it's just a pound sign for that first line. And then notice inside here, as he's actually creating certain things. And this is fascinating because you guys have learned that when you're instantiating a class and that you have your data fields, right? That if you think of Java, we create it, and right at the top we put a bunch of private variables that are the variables that really are those, I like to think of them as data fields, and then we create methods that correspond with those to be able to retrieve the values and change the values of those items, right? So the setters and the getters. And that's basically the approach that we use here in this language. It is a little different. So take a look at the approach. So the setter method, that's the one that allows us to actually set the value. Notice, just by virtue of syntax, the fact that we throw in that equal sign is basically telling us that we're taking whatever's coming in and we're applying it to that and creating it. But notice the inclusion of the @ sign before it, meaning that I'm not really changing the one that originally exists in the file. I am now applying a value and instantiating a fresh version. It becomes its own entity by virtue of that @ symbol.
If you look at the top line, you can tell that the language has to parse strings on the back end. You can't put a space between that equal sign and that
That's right.
parentheses value.
And it won't work. You're absolutely correct, Tom. Yeah, Tom is astutely noticing, by virtue of the way that they're placing stuff up on the screen here, that the interpreter in the back end reads through this. It does not want to see any spaces here around that equal sign. It just will not work because of the way the data is coming in. To actually just do a get for a data field, notice what you do here. There's no parameters being passed or needed because the data is assumed to be there. Remember, once you've instantiated that object and given something a value, that exists, so all you have to do is pull it back from that instance. And that's the way you do it. So getters and setters for first and last name. And then they do a thing here called full name, which just takes the two, concatenates them together with a comma and a space.
This is your model plan.
Yeah, well, this would be the example of doing, what we would do in a typical, like, Java program. But notice that we don't have to declare the variables at the top, but we have this approach for doing a getter and a setter. And once you recognize that equal sign and the parentheses and the value that goes inside, really what's happening here is this is not only a method definition for the setter, but it's also defining the data field at the same time. It's kind of doing it in one fell swoop. So in a sense, it's pretty efficient in that capacity. But if you didn't have this comment here telling you that, you wouldn't think of it in that capacity because that's not how you learn. If you learned, like in other traditional languages, we first declare the variables and then we get them and set them. So this language is a little bit different. All right. All right, so...
Does it matter? Oh, I'm sorry.
No, go ahead.
Does it matter if you declare them first?
Does it matter? Well,
I mean,
I suppose I've never tried it, but that's not how they do it in this language because it's not necessary. So since it's not necessary, they just don't do it. What would happen if you actually declared them first? I'm not really quite sure. I guess you could find out. Let me know. I bet you it would probably work. Would be my feeling on it, but it might not. It might cause problems with how the objects are actually instantiated. So.
Wait, what did you ask?
He was basically asking, in this language, we don't actually like pre-declare the instance variables.
Oh.
We just define them in the method and it
Right.
instantiates them. So he's wondering what would happen
If you just made variables.
if we made variables. Here's what would probably happen. You can't name a variable the same as a method. That's probably what would happen. That would be my guess. Because that's in essence what you're trying to do. So really we're kind of wrapping both capabilities together. Good question. Very good question. All right. So this next little example, he goes through and he starts to explain how some of this technology works. So for example, notice this first line here. He goes, at student. Please notice the fact that he's using a lowercase letter for that one. And then on the second one, he does student.new. Now, given the fact that we have this class pre-created, right? And he's calling .new. I didn't create a method in here called new, did I? So it just kind of works? You betch. I gotta stop being Sarah Palin here, sorry. All right, so what we're doing here is we're actually leveraging constructs of the language itself. So this is a method that kind of sits universal, and really what's happening is that's how we're doing a constructor, right? So we're instantiating a new student object. So this is the new object created from that class. And then once it exists, then we can start using methods within it. So for example, if I go student.firstname equals Bob, that's an assignment statement, right? We recognize whenever we see a single equal sign that whatever's on the right we're assigning to what's on the left. So what that's doing is it's jumping up here, it finds that first name method, sends it the value gets assigned, and it goes back to the instance.
It reminds me of JavaScript. You're trying to dub low in JavaScript, you end up doing
Yep. Yeah, that's exactly right. And that's because they're both interpreted languages, so they operate on the fly. So same thing with the last name, and then of course I can do the puts student.fullname. Of course that goes back to that instantiated version which has all those methods incorporated and should output jones.bob, just like what you see there. All right, the author continues here right at the top of the screen talking about what we just did. So what he's doing is he's kind of writing this for people who might not understand what object-oriented programming is, and I think that's kind of interesting, especially if you're coming into this language cold as maybe a first language. That it's a pretty heavy-duty concept, but those of you that understand object-oriented, when I say an instance and a class and you get that stuff. So that's important. But notice that they also have this little thing here that's kind of interesting, that we actually have kind of a shortcut way where we can accomplish the same thing. Isn't this interesting? So we have a way where we could have regular setters and getters like this, or we can do this attribute accessor, which basically says, oh, you want those data fields up at the top? That's kind of what you were really asking, right, John? What would happen? Well, you strip out the getters and the setters and you just say, what are your attributes? And notice how the attributes are defined. It's not like they don't just list them, right? They actually put them in as symbols. So it's kind of their way of doing exactly the same thing. And it is more elegant. It's much less code, and it provides exactly the same functionality. So we still get the capability of accessing these data fields, which now are technically symbols. We can get and set them. They can be instantiated. And then we have that one method that actually is one that it's not setting or getting anything, it's just doing something, which is outputting to the screen, or concatenating some stuff, basically. All right. Now he ramps up that example a little bit further. So let's take a look at this example. And this one he's calling team. And now he's using the attribute accessor up at the top. So really what he's saying is we have these two data fields, where name and students, we have the ability to get and set. We have really kind of automatic functionality that goes with that. But then we actually have some methods that do some things. And what exactly are they doing? So what's the first method doing? Let's extrapolate at what's going on here. He's initializing. Initializing is kind of like the first thing you do, right? So what is it doing? It's receiving a value. Could it be that when we're instantiating the object called team, that what's happening is we can pass it a name, right, clearly, if we call the initialize method. And it's also creating an empty array for us in which I guess we're going to put things into that array, but it's creating an empty one just by virtue of empty square brackets. Okay. The next one, he does add student. Now that one we're passing in 3 different values. So these 3 values are coming in to add student, and you can see from what's inside this method called add student and figure out pretty quickly what they're going to do. Now, doesn't this look a lot like what we were doing above in the example where we are instantiating student? Well, student is, hold on a second, student is that other class, right? The class that we already created. Notice that there is not an @ sign in front of student here. Because what's going to happen here is this stuff's going to get instantiated in the other class. That's what's happening. And then, wow, there's even weirder syntax. What's with the double arrow sign? Well, here's what's going on. There's no @ sign in front of any of these. We're just all putting it in this temporary variable called student, and student's got the capability of ID number, first name, and last name.
It's appending, isn't it?
That's exactly what it's doing. It's just waiting till the end, and once we have all that information in there, it's taking the information that's inside a student and all these little things here that it's adding onto it, and then putting it into the object of students. That's all that's happening. The next method is called print students. Well, we're taking the instantiated version, and we already recognize that when we see each like this, that it implies a for each loop. So for each student that's created, we will output the student's full name. Okay, so what we were discussing here is, the question was, so we're not naming like the students at this point. No, we're not. This is still a class definition, so this is still the blueprint for the object. And what he does in the example below is he'll create a variable called team, and then he's instantiating team, calling it rowing, and then as he's instantiated it, now team as a variable holds all of the capabilities here. So that includes the capabilities of this class and the previous student class that we saw. And then he's got the capability, since team is declared and instantiated, that he can start adding students and creating the students by virtue of kind of passing through the one class to the other. And really what we're seeing here, folks, is a concept of inheritance that you guys should have learned, right? So he goes very quickly from like what's a class and an object to all of a sudden we're doing a subclass and a superclass, you know. And if you guys remember like your Java homework where you had like horse and racehorse, remember that assignment? Yeah, this is the example. Or sandwich and sandwich ingredients, remember that? Okay. Those examples usually stick, so.
When we made sandwiches.
All right, moving on. There's a couple little things that we need to worry about in terms of convention, in terms of how we put our code together in an editor. Ruby does have some rules, and one, the big one is that whenever you do an indent, you always indent 2 spaces. No tabs, 2 spaces. But it doesn't say you can't tab. You notice the second bullet? Spaces are preferred to tabs. Now this is, I've seen programmers argue about this, and really funny actually. If you guys watch that one show on HBO, Silicon Valley, did you guys ever see the episode where like Richard, the main guy, he's very geeky, but he gets a pretty hot girlfriend, and she's a coder, but they broke up because she uses spaces instead of tabs in the code.
I've never watched that show. That's funny.
Yeah, it's really. how can you put spaces in? Tabs are much more efficient, you know. And they broke up because of it. So I'm just telling you, Ruby's got the convention you indent with using 2 spaces. So variables should be lowercase and underscored. So if you have like logical words, don't camel case them, do underscores. Method class definitions should include parentheses and no unnecessary spaces. So they give you an example of what's good and what's not.
It is worth pointing out that those are all suggestions.
Right, not rules. You won't break your program if you don't follow these suggestions, but it's something that's important to know. All right. If you guys are interested in learning more about Ruby, because really the pattern that we use here in this class, and really the point that you guys are at in your programming experience, you guys need to start switching that, or flip that switch in your head that tells you this is just another language, all the concepts are the same, this is how I do it in this language, and you're not really going to get too much more instruction on the structure and the usage of this language beyond this chapter. We're just going to be digging in and doing stuff. And then if there's something you need to figure out, you need to know how to go figure it out. So the best place to figure it out is at the Ruby website. And they do have some links here. I don't know if these links are still active. Let's find out. I guess so. May as well check all of them, right? All right. So if you want to read up on the documentation for the language, it's out there on the web. Best place to go is the Ruby website. And there will be times where you're going to want to figure out how do I do this in this language? And really, you know, you're not really going to find as many textbooks on this as you would like on Java. So what you have to do is know how to research it and go find it. So you should get into your head the concept, folks, that whatever language you're interested in learning at this point, it shouldn't take you much to get past the basics. Like, you should be able to sit down with a book, look at the data types, the syntax, how you structure things, how you do a loop, how you do a variable, whatever, and get rolling with it pretty quick. And so if there's other languages that you want to learn that go beyond what we teach you here at Gateway, you are armed with enough basic knowledge when you get to this course that you should be able, if you want to pick up Python, you want to pick up C++, or whatever it is, you should be able to go out there and do it without a lot of rigmarole. Sure, to get good at it, you'll have to work at it, of course. Folks, that is the chapter. Made for a lightweight night, which is good. I think you guys kind of need it. We are coming up on midterms, so make sure you study. And this video ends here.